Hi everyone, this is Mr. O'Gal, and in this video we will be looking at definitions and theorems of circles. So let's get started by looking at a few definitions. I'd like you to pause the video, match the words from this column to the pictures in this column, and hit play when you're done. Ready, pause. Alright, here are the correct answers. I'm going to go over a few of them. The first is concentric circles, and that's E. They have the same, two circles that have the same center, but different radii. The next one I'd like to go over is number 4, a chord. And that goes, it's a line that goes from one edge to another in a circle. So that would be A. The next one I'd like to go over are major arcs and minor arcs. So the minor arc is smaller than 180. And a major arc is greater than 180. So the minor arc is from R to Q, and the major arc is from P to Q to R, and that's greater than 180 degrees. Alright, pause the video, write down any definitions that you want, and hit play when you're done. Ready, pause. Alright, there are two more definitions that I'd like to explicitly look at, and that's central angle and inscribed angle. Central angle are, for example, AOB, this one right here. Another example of a central angle is DOA, that's this one right here. And a third central angle would be DOB, that's this one right here. These are all central angles. They come from the center of the circle, from the center. And an inscribed angle. So here we have ABC. This one is inscribed. We have BCD. BCD. This is inscribed. And another one that's inscribed would be CDE. And these are angles that come from the edge of the circle. Pause the video, write these two definitions down, including drawing the picture, and hit play when you're done. Ready, pause. Okay, so now we're going to look at three properties that have to do with chords. The first one says, if two chords in a circle are congruent. First, we need to look at those chords. That's A, B, and C, D. These are the two chords. Then they determine two central angles that are also congruent. Pause the video, write this down, including drawing the picture, hit play when you're done. Ready, pause. Okay, let's quickly talk about the proof behind this. If these two are congruent, we know that these two sides are congruent because they're radii, and these two sides are also congruent from their radii. My two triangles, ABO and CDO, are congruent because of side, side, side. Therefore, the angles are all congruent using CPCTC. Remember that? We're bringing it back. Alright, the next one is a chords arc conjecture. If two chords in a circle are congruent, and we're looking at these two chords, then their blank are congruent. Now, if those two chords are congruent, we know that their central angles are congruent. And if those angles are congruent, then their arcs are congruent. So if this is 50 degrees, then this is 50 degrees, and this is 50 degrees, and this arc is 50 degrees. Pause the video, write this down, and hit play when you're done. Ready, pause. The last one I'd like us to look at is the chord distance to the center conjecture, which says if two congruent chords in a circle, so we're going to look at these two chords, 1 and 2, are blank from the center of a circle. They are going to be equidistant from the center of the circle, so that means that this little part is congruent to that little part, and this part is congruent to this part. Pause the video, write this conjecture down, including drawing the picture, and hit play when you're done. Ready, pause. Great job, everyone. You now know 3 very important theorems about chords, and I can't wait to practice these in class. Thank you.